In this video, we are going to take a look at balancing chemical equations. So, chemical equations are balanced to show the law of conservation of mass. Okay, and the law of conservation of mass says that mass is neither created or destroyed in any ordinary chemical reaction. Okay, the mass of the product, so what does this mean? It means the mass of the products is always going to be equal to the mass of the reactants, and a chemical reaction is considered balanced when we have the same number of each type of atom on both sides of the equation. Okay, when we balance a chemical equation, we want to remember that we can never change the chemical formulas for the substances. Instead, we are going to add what are known as coefficients in the smallest ratio possible. Okay, coefficients are whole numbers that appear in front of a chemical formula, and the coefficients in a balanced equation below are listed in bold. So if we take a look at this chemical equation, the 2 here and the 2 here represent the coefficients. The coefficients, again, are what we want to add when we're balancing a chemical equation. The coefficients in an equation can be distributed to each one of the atoms in that formula. So for example, by adding the coefficient of 2 in front of the SO2, it tells me that I have 2 sulfurs. And if I multiply the 2 times the 2 for the oxygen, it's going to give me 4 oxygens. Okay? So if we take a look at this equation, the coefficients on each side make sure then that there are 2 sulfurs and 6 oxygens that are found on both sides of our equation. If we have no coefficient written, like in front of this oxygen here, we assume that the coefficient is 1, okay? And just like when we write chemical formulas, we never write the coefficient of 1, just like we wouldn't write the subscript of 1. Okay, in this example, again, if we take a look at the left-hand side or the reactant side, we have 4 oxygens in this compound here, but we also have the 2 oxygens here, so on the left-hand side of the equation, there are a total of 6 oxygens. Okay, so now we're going to take a look at some practice in balancing some of these chemical equations. So if we take a look at this first example, NCl3 yields N2 plus Cl2. Okay, when all is said and done, we want to make sure that the left-hand side of this equation and the right-hand side of this equation are equal. Okay, to start, we can just kind of take a look at the numbers and types of atoms that are found on each side. So on the left-hand side, as written, I have 1 nitrogen and I have 3 chlorines. On the right-hand side, I'm going to have 2 nitrogens and 2 chlorines. Okay, by looking at this, I can see that my equation is not balanced. The number of nitrogens and the number of chlorines on either side of the equation are not the same. So from here, we're going to start adding coefficients. It does not matter where we start adding the coefficients, but what we want to know is we can never decrease the number of atoms that are found. We can only hope to increase it. Okay, so if we take a look here, the thing that immediately stands out to me is the fact that we have 2 chlorines on one side and 3 on the other, okay, or 3 chlorines on the left side, 2 chlorines on the right side. In order to balance this, we want to use the lowest number ratio, and so the lowest common number between 2 and 3 is going to be 6, which means that we're going to try to get 6 chlorines on either side, or on both sides of this equation. So when I look at the left-hand side here, I want to think what number, when I put here, multiplied by 3 is going to give me 6. Okay, and that's going to be a 2, so I'm going to add a coefficient of 2 here. On the right-hand side then, I'm going to think about the same thing. The number that I can add, that's going to give me 6 is a coefficient of 3. So I had a coefficient of 3 on the right-hand side, a coefficient of 2 on the left-hand side. Okay, by doing that, that changes the number of chlorines here to 6. It's also going to change the number of chlorines here to 6. Okay, on the left-hand side, it is going to change the number of nitrogens that I have to 2. And so now I have a complete balanced equation. I have a coefficient of 2 in front of the NCl3 and a coefficient of 3 in front of the Cl2. Again, although it's not written, we have a coefficient of 1 in front of the N2. Okay, let's take a look at another example. So once again, I'm separating the left and the right-hand side. As written, I have 1 copper, I have 1 silver, and NO3, I have 1 of them. Okay, this is a polyatomic ion. I have one NO3. There's no need to break it up into N and into O. Okay, on the right-hand side then, if I go in the same order, I once again have one copper, I have one silver, and with this 2 here, I now have 2 NO3s. Okay, so when I look at this, I can see so far my coppers are balanced, my silvers are balanced, the nitrates are the only thing. I have 1 on the left, 2 on the right, so my best bet is to add a coefficient of 2 on the right-hand side. By doing that, that's going to change the number of nitrates to 2. It also changes the number of silvers to 2. Okay, so now when I look at this, I've balanced the nitrates. Okay, my coppers are still balanced, but in balancing the nitrates, I've changed, or my silvers are no longer balanced. So to balance my silvers, I would go to the right-hand side and add that coefficient of 2. So sometimes when we balance equations, we have to go back and forth from side to side until all of the atoms match up. Okay, finally, my last one here, I'm going to do the same thing. I'm going to start by listing what I have. Here I have 1 carbon, I have 4 hydrogens, and I have 2 oxygens. On the right-hand side, I have 1 carbon. I'm going to go in the same order here. I have 2 hydrogens, and this time I have oxygen that's found in 2 spots, here and here, so I have to account for that. So I have a total of 3 oxygens on that side. Okay, in these types of reactions, we typically want to balance oxygen at the end. So we're going to start by balancing our carbons first. Our carbons are balanced. If I take a look at our hydrogens, in order to balance our hydrogens, we're going to need to add a coefficient of 2 in front of the water. By doing that, that is going to give me 4 hydrogens. It's also going to change the number of oxygens, and we don't want to just multiply this times 2 down here because that's not going to be correct. Instead, I'm going to recalculate. I once again have 2 oxygens in the CO2, but now I have 2 oxygens in the water, so 2 plus 2 means that I have 4 oxygens on the right-hand side. Okay, so my carbons are balanced, my hydrogens are balanced. The last thing I need to do is balance the oxygens, and I can do that by balancing or adding the coefficient of 2 in front of the O2. Okay, just like everything else, balancing equations becomes easier the more and more that you practice them. So to start, you may need to write everything out, but eventually most of you will get to the point where you can look at an equation, you can add the coefficients to balance it out.